Okay, here's PowerPoint lecture number 2. Turn up the volume to hear me. 1, 2, 3. So you remember the first discovery, the ancients could do this. They could darken a room and put a hole in one wall, and then the natural phenomenon of light coming in would form an image upside down and backwards inside the room. Abelardo Morel photographed this phenomenon. He's standing inside of a room in which a hole is in one wall, and it's projecting the image outside, upside down, and backwards. And so he's recording a camera within a camera. Reference to this was found in 15th century writings. It said, "Close all shutters and doors until no light enters the camera except through the lens. And opposite hold a piece of paper which you move forward and backward until the scene appears in the sharpest detail." Basically, you're focusing it. There on the paper you will see the whole view as it really is. You can trace the whole perspective with a pen. So these were the first cameras. Instead of film or a chip in the back, they would trace what they saw. So the first cameras as we know them were portable rooms that they'd walk around with, and instead of using film at the back, which wasn't discovered yet, they would trace what they saw, or what was coming in through the projection. So this was the optical aspect of the invention of photography. The camera obscura, dark room. But it just wasn't enough for some people. They wanted an exact copy of the image. Tracing just didn't do it. So one such a guy was Louis Daguerre. He was a showman who put on great spectacles using lanterns of light. Remember, there was no electricity. They had to use torches and colored glass to project shadows and move backgrounds and backdrops and the like. It was all done live. There was no recording medium. So there were spectacular movies back in the day, but they weren't recorded as we know them today. But let's go to the chemical aspect of the discovery and the history of photography. Certain silver salts darken when exposed to light, proportionate to the amount of exposure, meaning that the more they get exposed to light, the darker they become. There's a story, an illuminative story, that says here was this apothecary owner, and he had all his chemistry up on the shelf, and each thing was in a jar, and it was labeled. And one of them said silver salts, this jar. It said silver salts on a label, and one day he noticed that his silver salts had turned black. And when he pulled away the label, beneath that label it was still white. And he made the connection that these silver salts were reacting to light. Whether the story's true or not, it still illustrates the idea that silver salts will darken when exposed to light. So let's look at a quick overview of film processing. You would come upon this beautiful scene of the sunrise, and you pull out your camera, load it up with film, set your aperture and your shutter speed, and you would take the picture. The silver salts on the film are stimulated when the light hits them, but what you've got is a latent image. The image still needs to be processed for it to come out. So the film is processed, it's developed, and the latent image is brought out. You'll notice that where the sun was the brightest, on the negative it's the darkest, because the silver salts received a great amount of light, so they turned quite black. And where they received little light, they remained white. So now you've got a negative, and you go into the dark room with that negative, and you go first to the dry side. There are two sides in the dark room. There's the wet side that has all the chemistry, and then you have the dry side. In the dry side there's an enlarger. What does that look like? I'll turn it sideways. What does it look like? Yeah, it looks like a camera, except the light is inside of the camera and coming out rather than going into the camera. So you're reversing the process. You place your negative into the enlarger and you focus a lens and you project that negative image down onto a piece of photo paper beneath the enlarger, and that photo paper has those same silver salts that are ready to be stimulated. The photo paper needs to be in a dark room. If you were to bring it out and light hitting it from all angles, it would simply turn the whole thing black. So you got to control that exposure. You got to focus an image onto that photo paper. When you do that, the light stimulates the silver salts. So just as it happened in the film, it's happening on this piece of paper. And again, you have a latent image. So you have to take it over to the wet side for it to be developed. In the wet side, you have three chemicals. You have the developer, the stop bath, and the fixer. First thing you do is you drop it into the developer. And this is what happens. It slowly comes up in the chemistry. If you were to leave it in the developer, it would overdevelop. The chemistry would destroy your picture. So what you have to do is drop it into the stop bath. In the stop bath, the developer is simply neutralized. Your paper is still sensitive to light. If you were to bring it out to show somebody in white light, it would be ruined. So what you have to do is fix your image onto the paper. You drop it into the fixer, and the fixer is a very appropriate name. It removes all the silver salts that are still sensitive, and it fixes those silver salts that have been sensitized to your paper. And you leave it in the fixer for a while. After a while, you can turn on the white lights, the room lights, and you'll see your image. You then wash it very well, and then you hang it to dry, your print, and then you hang it to be admired. So there were experiments going on with these silver salts, but there was also this other material, a form of tar called bitumen of Judea, and it's hardened by the action of light. Silver salts darken, and bitumen of Judea hardens by the action of light. And so one guy decided he would play around with this to create images. Nicephore Niepce in France, he took a piece of pewter, 8 inches by 6.5 inches, and he coated it with this bitumen of Judea, this tar. He brushed it on, and he put it into the back of his camera obscura and focused an image onto that as he pointed at the camera out of his window. And this is the image that came up, a heliograph. Helio meaning sun, so it was called a sun drawing. Over 8 hours of exposure, the sun had moved from east to west, and so you get this odd image in which the sun is shining both on the inside of the west face of turrets and the inside of east facing turrets. In order to process this pewter plate, after 8 hours he pulled it out and then he rinsed it carefully. Wherever the tar was hardened by the long exposure of light, it stuck to the plate, and wherever it received little or no light, that was washed off. So now he had a negative. He had this dark plate with tar stuck to it. In order to create the positive, he took lavender cream. Lavender is the flower we're all familiar with, and it's creamed to create this white gel, and he carefully smeared it on. Wherever the tar was still there, it grabbed and held on to that lavender, and the black became white. So thankfully we don't use this process anymore today. You could try it at home if you wish to get extra credit for it. A year later, he was experimenting with skylights, in which the sun, as it moves across the sky, it doesn't change the position of shadows. The light streaming down remains the same. So, but it takes 10 hours of exposure, a little longer to expose. But things started to appear with normal shadowing. So shortly after these experiments, Nicephore Niepce dies, but he's still given credit, along with Louis Daguerre, as being one of the inventors of photography. There's all kinds of controversy because in England there were other gentlemen that were creating forms of photography, processes of photography, but Daguerre kind of gets credit for springing upon the world the first viable uh, system of photography. In 1839, he announces the process he calls the daguerreotype process. Here he takes this silvered copper plate and he coats it with silver salts, and he puts it in the back of a camera obscura, giving it exposure time, and then that has to be developed in mercury vapor. We all know what mercury does to us, so the early daguerreotype photographers were compromised in their lifespan because of this process. Daguerre received a stipend from the French government, a pension, for revealing this process to the world. And suddenly, around the world, people were setting up daguerreotype studios in order to shoot in that photographic media, the new photographic media. The daguerreotype is a direct positive. There is no negative. So the image that you see in a daguerreotype is reversed left to right. The fact that the camera obscura created the image left to right inside of it. The upside down and right side up can be overcome by simply turning the image right side up, but the left to right couldn't be overcome. So daguerreotype studios started popping up all over the world. And people came to these daguerreotype studios to have their portrait made. It was expensive. They might pay as much as a month's salary to have their portrait made. You got to remember that in those days there was no electric light yet. So daguerreotype studios were typically inside of a big glass building so that the sun could come through. And on cloudy days or rainy days, they wouldn't be able to operate. They'd be closed. Here's Walt Whitman circa 1850, the poet. So here's a daguerreotype. It's of Samuel Clemens, Mark Twain, author of Huckleberry Finn, The Adventures of Tom Sawyer. He was an apprentice to his brother. He was an apprentice in the print shop, and he knew that when his daguerreotype came up, it would look like this, and it would say Sam in front of him. He's actually sitting in front of the camera like this. Notice that the print block letters appear to be backwards. He knew that when his daguerreotype came out, it would look like this. Sam being properly oriented. So he's playing an interesting trick on us. The old-time block letter printer setters had to work backwards. You can see the quick brown fox jumped over the lazy dog, all backwards. When it's pressed down, it becomes the positive. I have seized the fleeting light. 1839, Louis Daguerre. Here's a daguerreotype photographer pointing at his subject. This is outdoors. It's the backdrop and the light is set up to make it look like it's indoors. It might be in a big glass structure to keep out wind and the like, but it only could be done on bright sunny days. So again, it cost a lot because there was only a short time that they could bill you for it. And those of you that know business would know what billing time means. So here's a recap. The camera obscura, dark room, that was the first camera. Today we simply call it camera, but back in the day they called it the camera obscura, the apparatus that created images without film. They simply would trace what they saw and then paint over it if they wanted to do it that way. Louis Daguerre, Nicephore Niepce. There are others that are considered founders and inventors of photography. The daguerreotype, which is a direct positive image. It's made, and when it's developed, it doesn't come up as a negative. Today, our digital cameras give you the same idea. We don't have a negative positive process anymore. The image comes up as a positive right away. But we don't have this drawback in which the image is reversed left to right. So anytime you look at a daguerreotype, you're looking at the person backwards. If you really wanted to see what they looked like, you'd hold it up to a mirror and see that the part of their hair goes in the opposite direction. Silver salts, the idea that there's this chemical that reacts to light, and latent image means an image that's waiting to be brought out. And heliograph being the sun drawing, the first image created inside of a camera obscura. So what are the basic parts of a camera? Let's look at a pinhole camera to get an idea of what these parts are. Well, first obviously is the box. Camera is a box. It's a room, right? So you start with a box. Then you put a hole in it. You put the aperture into it. Then you put a shutter over the hole. In this case, it's a little sliding piece of wood that goes up and down to cover the aperture. And finally, you put film inside so that it records what's coming in, the image that's coming in. The pinhole camera is a viable camera. You can use one today, but it has its limitations. A pinhole camera requires very long exposure times. The hole is very small and light just trickles through it. It also produces an image that has soft focus. The soft focus is because this pinhole is allowing some scattered light to come through. As you start making the pinhole larger, even more scattered light comes through and the image starts to degrade. But we're not going to use a pinhole camera. We're going to use the DSLR. Let's look at the parts of a DSLR, digital single lens reflex camera. It has a lens. The lens sharpens the image that's coming through a bigger hole. We want to work with a big hole so the light can come in fast. The lens sharpens that image. Then there's an aperture. The aperture inside of the DSLR is variable. It can open and close according to what we want it to be. It's a variable diaphragm. The shutter, of course, is there. It controls the length of time the film is exposed to light. And then in the back is the chip. In the old days it was film. So those are the basic parts of the camera. The lens, the aperture, the shutter, and the chip. So what a lens does is it lets us work with a larger hole. Notice that the image is still coming in upside down and backwards. The aperture is basically an opening. It's a hole, and it's usually part of the lens, and it's usually variable. Just like the iris in our eye that opens and closes automatically as you walk from a dark room to a light room. The camera can do that automatically when it's in auto mode. Otherwise, we set it in manual mode. And the shutter is probably the easiest thing to understand. In this camera, it's just that cap. You would open the cap, you'd count to 10 or whatever it takes to get proper exposure, and you put the shutter cap back on. and the camera started to evolve. Then it got a little bit smaller, and flash was added as new technology was developed. And then it got smaller still when the digital world came in. And then today's workhorse, the DSLR. So SLR means single lens reflex. When you put up a SLR camera to your eye, you're seeing what you're going to get. It's WYSIWYG. What you see is what you get. There's a system of a mirror and a pentaprism that changes the image that would otherwise be upside down and backwards to right side up and corrected left to right. Here's another cutaway view of the same thing. That light beam, the blue light beam, comes through a series of lenses. A series of lenses allows for even more precise sharpening. Notice that the hole is pretty big because the lenses are big. A pinhole camera would allow the light to trickle through. These larger lenses allow light to come streaming through. That light beam hits the mirror that's on an angle, and it goes up through that pentaprism, that five-sided prism, and goes into your eye. When the picture is taken, the first thing is that the mirror has to get out of the way. The mirror jumps up out of the way, and notice the focal plane shutter is behind the mirror. So when you take your picture, you hear that ka-chunk sound that the SLR makes. It's the mirror getting out of the way. The mirror jumps up, then the shutter opens and closes, and then the mirror comes back down. Today we have the electronic viewfinder. It too is a WYSIWYG. It's what you see is what you get. As you point it around the room, you'll see the image right side up and in the correct orientation. A little TV screen going on. What you see is what you get. WYSIWYG. It's a little TV screen. It's hard to focus. So autofocus is a good thing to use with this system. Okay, so this ends this lecture. What you should do now is go and read your camera manual. Find out things about it, play around with it. We're going to shoot in what's called manual mode. In that mode, you can control aperture and shutter speed and ISO independently of one another. So look that up. See how you can change your shutter speed and your aperture in manual mode. Thank you.